Welcome to this Kettering Robot in 3 Days stream. Here's our robot. We'll go right into the details of it, starting off with our intake here. This was designed, cut out of Lexan, and then it uses a 1x1 air tube, or maybe thicker tube for support, just to keep it more rigid. We have a solid dead axle across the front to keep the end from falling apart. And then after that, we have it just supported on the ends for these upper two rollers. Our bag here has a 9-to-1, right? Yeah, 9-to-1 gear ratio on it. And it's just belted back and then back down to the front of our intake here. It's mounted on a 4-bar so that it can come in and out to start the match and then also to stow away so it's safe from other robots or hitting the walls.
This First Updates Now video is sponsored in part by Stryker and Kettering University. Stryker is a leading medical device company and is looking for those in FIRST to join their team as interns or for a great career. Come join a company that will actively support you being in FIRST at careers.stryker.com. Kettering University is a national leader in experiential STEM and business education. Discover why so many FIRST alumni come to Kettering University by scheduling a virtual visit at kettering.edu.
And then that'll lead it right into our hopper here. Nick, you want to take over?
Will do. So my name's still Nick, mechanical lead for the Kettering Bulldogs, and this is our hopper subsystem. So it's pretty hard to see, but there are two bag motors on 7-to-1 versaplanetaries kind of nested back in the middle of the robot. 7-to-1 might be a little bit of a fast gear ratio, but honestly, it's just what we had on hand, so take that as you will. And they just have timing belts that come lead outward up to these two rollers. That it's just a pretty standard belt hopper. You saw a lot of teams solve the indexing challenge with them this year. It can hold 3 when the intake's closed, 5 when it's not. I don't have 2 more, but you're just gonna have to take my word for this one. And even though these are both on bag motors, which legally you could route them to one motor controller, we did allocate 2 motor controllers to these so we could do things like run them at different speeds to clear ball jams up. Oh, I guess it's still me. So that is leading right into our shooter mechanism. So the V-hopper takes balls and they funnel them directly into here. I'm just going to put 1 ball here. Oh, I guess we're adding more. So time travel back, it holds 5. You don't have to take my word for it anymore. So the V-hopper funnels balls directly right to this area. There's a bag motor, which I think is also on a 7-to-1 versaplanetary. Is just hooked directly up to a Versa roller. So when we want to fire, this Versa roller starts spinning and it kicks the ball directly into these 6-inch Andy Merck wheels that are direct driven by 2 Falcon 500s. If you were with us around the start of the stream, you'll remember that we had the Falcons here and they belted to the shooter wheels, which gave them a little bit of a reduction. But due to belt tension issues, we had to move them directly here because it was just tearing the belts off of the shooters. The hood is non-actuated. It's just a static hood. We designed it so it would go into the upper port just from the target zone, so we can't shoot from the trench, but still think it was a pretty viable strategy for this year's game. All right, that's pretty much it for the hopper and shooter. Then if you guys want to learn about our climber.
Hey, before we get into that real quick, if you didn't see in chat, by the way, we're giving away some Kettering University t-shirts. So if you're interested in winning those, we got 5 to give away during the stream. Between now and the other matches, make sure you type in Bulldogs in chat. Right now, that's your opportunity to win. And don't forget, you need to be following channel in order to win. We'll be drawing for those throughout the stream.
All right. By far the most rushed portion of this robot here is our climber. This is a linear 3-stage climber. It has 2 constant force springs pulling it up. It's sort of a bit of an exposed climber, so that way we didn't have to route the constant force springs down into tubes, so that's just all in the open, easy to access, easy to work on, easy to fix. And then that's just so that we can lift up this first stage here, and then after that we have a cascade style lift going to the second stage, which is just a piece of fiberglass rod, and that's just in a 1/2-inch piece of PVC. Our little side PVC guides are 3/4 inch, and then these are 1-inch couplings that ride on it. It's surprisingly smooth considering it was made entirely out of PVC. Oh, and then also we have 1-inch PVC couplers on the top here, just as constant force spring bearings, so that way they're free to spin. And then we just have the U-bolt hook that I believe was used on the every bot. So just grab that off of a every bot climber that we had lying around. If you needed to build one of these within a small space with a very tight budget, if you ran out of budget, this is a pretty good climber. But if you have the room, probably recommend the other one. It's just a little bit easier to work on and a little bit more consistent. So now on to...
All right, I'm Eric. I'm going to be going over some of the things that we learned while fine-tuning the robot. So with the V-style hopper, it's really good for getting the balls to move around. However, there's one major issue where if you have the balls side by side with each other, they're not going to go in the robot. One way we tried to fix this, which I know works for some teams, you run one hopper slightly faster than the other. This works for some jams, but if they get wedged slightly too far in, say you have a third ball pushing them in from the intake, that no longer works. So one of the things that we actually had to do was go back in and then make a command just to run the hopper backwards, just for like at 40% power, just as long as the operator is using it. And so that's one of the ways that we clear out the hopper. Going back to how it holds 5 balls most efficiently, since our intake is actually really good at getting the balls through. Because we chose a really out there bumper material, we have some issue with certain balls not wanting to come in. But once they get in the robot, they just fly up. So one of the ways that we addressed that was adding these little side flaps. You'll actually kind of see it every so often. They do just hit it and then bounce right back in. It's really beautiful to see because they were just cut with they were just cut on the robot. It wasn't that pretty, but they work really well. And then on top of that, so back to the intake, while it's definitely wide enough to pick up 2 balls, we don't want to run the intake at full power simply because if we do that, the balls are just going to shoot all the way past and off the robot if we do. So what we did to account for that was we just ran it at 85% power. And then if you grab 2 balls at once, you just have to outtake it for a moment, turn the robot slightly, and then just get one in before the other. As long as they're not perfectly side by side, they do come in relatively well. Then for our just shooting sequence, we have it so that our shooter revs up to 75% power. We give it we have 2 ways of shooting. We have one where it's a manual control and the driver just holds down the trigger and then whatever they want, they press the manual shoot button. That then runs the indexer to let it go to, runs the indexer and the hopper as well as the intake all in one command. Then all the balls just funnel through to the shooter. One issue we found with that, just because of how we programmed it, was that our shooter would stop running the moment you pressed any controls on the on the controller, which was really awkward. So we spent most of the day today trying to figure that out. We ended up making an automated sequence that just lets it rev up to 75% power, and then all the systems just run on your own. So the driver can press it while driving up, and then just shoot all the balls in the robot all at once. So that's all I really have for the lessons learned about the robot. We haven't really gotten to test the climber out too much. Hopefully, maybe we'll be able to do that later. It all depends.
So are we able to turn on the robot and kind of show off some of the features and capabilities while we talk about it?
Yeah, sure. Noah, here.
All right.
And chat, I did mention we're going to name the robot. So we're going to start a poll that we have. It's a 10-minute poll. And you can use fun bucks if you have accumulated some of those to vote for additional votes. So here are the 4 options. They're going to show up. There is Brutal, Downtown Danny, Speedrun, and Nick with a period at the end. Were there any others from the Bulldogs team for suggestions? Corner Slice. All right.
Corners.
We'll type that in a second.
Uh-huh.
All right, so there's going to be 10 minutes. The poll is now up. Whatever you choose is what the robot's going to be named. So once again, 10 minutes. We'll check in about 5 to see what people want for this as well. And don't forget, we'll be drawing for those giveaways throughout the show. Hopefully it's not everybody who's won once already, but we'll keep doing that more and more as we do have 5 shirts to give away. So yeah, let's go into some of the robot features as it's turned on and watch it perform a little bit.
Ready to go? All right. Well, starting off with the intake, we'll be able to see that one run. One nuanced thing about our intake that we realized is it actually helps being a lot lower, because when our intake was a little higher, so it just grabbed the balls, it looked like really nicely, it would actually pull them underneath the robot. But when it's lower, it kind of crushes them and then pulls them right up. Go ahead. And now onto our hopper. I'll give it a bit of a sticky situation with two balls next to each other. Go ahead and run that. And you can see it pushes one out and pulls one in, gets them ready to shoot. Do you want to turn around and shoot, or? So you can see those ramping up to 75% power. Once it's there, manual controls, shoots them right in. All right, you want to actuate the intake out just so they can see that as well. That's just some simple pneumatics on a solenoid. Most of this robot is quite simple, so it should be pretty easy to duplicate if you want to do that on your team. Is there anything I forgot? No? Any questions in chat? Oh yeah, let's just show it off.
Chat, don't forget, if you got any questions, make sure you type that in chat here. It does help if you do have first updates now for that, but we will try to grab as many questions as we can through this as they're showing this off.
Uh-oh, climber got caught.
Oh, that's new.
That is.
So just a quick FYI, the climber was thrown about 30 minutes ago. Haven't had time to guarantee its integrity. So
that means we're definitely going to see it
oh.
climb, right?
Sure.
Or fail trying.
Sure. Yeah, so it's currently stuck in the drivetrain. We'll get that figured out really fast. And then show you the volley.
So why don't we grab a couple of questions real quick too, and you can answer as we go through. I know somebody earlier asked asking more about how the electrical was done on your robot, and was there a certain bedpan style that was done on it?
So I'll talk about the belly pan real quick. I'll let Eric handle the electronics. There isn't any belly pan in the back of the robot. We're just using the kitbot frame. But for the front, we just used a polycarbonate sheet that covers about the first half of the frame. Eric, come back. That the electronics are mounted on. All right, he's long gone. The electronics of the robot, nothing crazy, I guess. Standard FRC electronics. There's really nothing wild about them. I'm going to talk slowly so he can come back and take the mic.
So the electronics, it's not the prettiest. They're all just kind of stuffed under the hopper, if I'm being completely honest. Our PDP is relatively central, and we had a nice spot right under the back of our shooter for the RoboRio. There's really not too much to the electronics. Like we're not using any sort of special sensors. It's a really bare bones system. The compressor, as you can see, it's kind of just shoved into the back, as well as the two tanks. So it's honestly a really simple system. The only thing plugged into the VRM is the radio, and we only have a single solenoid, which is just running to the intake. So use one solenoid to actuate both of them at the same time.
So somebody asked in regards to the robot itself. So of course we have infinite recharge at home, and then the actual game. So how was this robot built to? Was it meant to accomplish one or both, or can you go a little bit more into that?
So we initially set out to design it for infinite recharge, the normal game. As we went on, today we started to look back and say, okay, let's start to look more at the infinite recharge at home, just because we knew we wouldn't have enough time to get the full 4 to 5 that we wanted to work on. So we went back, we started to look at infinite recharge at home, and we said, yeah, this can do most of it pretty well. We won't have to. We don't really have the time to get too much into the first two of the skill challenges since they rely incredibly. Well, they're literally just based on autonomous, so we don't have time to focus on those. But there's really only one that it would fail at, and that is the one where you have to shoot from all 5 zones, since it's specifically designed to shoot at the front.
Our shooter is also quite flexible, so if you wanted and you had the time, you can adjust it to shoot at different locations. You could do that with pistons to have it adjust and shoot at different spaces, or just hard set it at a point that works really well for you. This is just a lot of tuning. As we've seen with the previous season, the balls are a little bit finicky, and you just have to kind of try and get it better and better. So this hooded shooter could be used for shooting further away. We just have it set up to shoot close because that's what we had time for.
So let's just do a quick check-in on the naming of the robot so far. We got about 3 minutes left on the naming, and right now with 57% of the votes, it's Nick Period winning it, followed by Corner Slice with 35% of the votes right now. So once again, if you want to get your votes in, you got about 3 minutes left to do that. And don't forget, if you got any questions, make sure you type them in the chat. And we do have some more giveaways. And by the way, if you do win a giveaway, please make sure you send me your mailing information and what size shirt you'd want. Just like the next giveaway we're doing here, which is going to go to VEC 702. Congratulations on that. We still got 2 more shirts to give away throughout here. So can we detail, after we go through this, what are we going to be doing first for the challenges? Are we going to do the at-home challenges first, regular match first? What do you got? What do you got in mind?
Looks like we're better set up for a regular match, right? Yeah, so we'll probably be doing a regular match first.
And is the climber all set?
No.
No? We don't think it's going to work, or no?
Unfortunately, we don't have it wired or programmed.
Okay, so no climber.
No climber from this guy unless we can get some jumper cables and a battery.
Okay. And are we able to do a 1v1 match as well?
I guess so.
Okay, so we'll try to see that as we go through. Stegs 85, you don't have to say it after each giveaway. No, you can just type Bulldogs in once. They'll enter you in for all of the giveaways. So once again, about 2 minutes left to name the robot on here. Sporky says that he's Sad Howard for no climber, by the way. So any other challenges you want to talk about? Maybe advice for teams who are looking at doing the at-home challenge, or if they are looking at modifying their robot for this year, even for the regular game as well.
I don't have any great specific advice for terms of that. I guess I'd just say do what your team's capable of. Don't feel guilty if you can't meet in person to make. I heard some talk on Discord about how some teams are making robots specifically to address some of these challenges. Don't stress that hard if you don't have the resources or you don't have the capabilities to do that. Just take the challenges as what they are and do the best you can with your robot. And if you want to tweak it to do better at them, world's your oyster, right?
Another thing to add to that is this game, a lot of things are a little finicky with this. The balls are really sticky, and you just got to try things. So if you've got a robot that's okay, don't feel like you have to go and rebuild the whole thing to make it a great robot. You can just keep playing with it, and every time you see a little problem, address it and see if you can tweak it to make it a little bit better in that little way. This year is really interesting for that because we have tons of time to do tuning, programming, and testing to get our robots nice and battle ready, which we've never really had in the past.
Yeah, so there's really only one challenge that would require heavy modification of your robot. That's the one where you have to score from the 5 zones. So if you don't have the resources, that would probably be the one that I say do not pour the money into. The other 4 you can do with just any robot that you built for infinite recharge, because they're just basically score from almost wherever you want, and the other 2 of them are autonomous. One of them is just driver skill. So as long as your robot can drive, you can do 3 of the challenges. As long as it can shoot in some way or form, that's another challenge you can do. So there's 3 that are basically given to pursue as long as you drive. That's all the advice I would have. Just spend your time wisely.
All right, we do have a winner, by the way, for the robot name. And looking with a large percent of the vote, 53% of the vote, Nick Period has won for the robot. Excellent. There we go. So yeah, Nick Period will be the name of the robot. Everybody's excited, right? Yay! So thank you, chat, for that. With 101 votes, Nick Period takes the naming of the robot. So yeah, Corner Slice in second place, by the way, followed by Brutal. Brutal only had 6%, so it was really down between Nick and Corner Slice. Corner Slice had 39%, and nobody really wanted Downtown Danny or Speedrun. So, all right, it doesn't look like we have any other questions at this time to go through. So I think we're going to set up and do a couple matches. I think that's the idea, right? All right,
Sounds
so
good.
we'll set up and do that. You'll get to see, I think, the other robot, the 2021 as well, too. So enjoy that as well. This First Updates Now video is sponsored in part by Stryker and Kettering University. Stryker wants you to come work for the leader in innovative medical devices with some of the industry's best pay and a company that supports your first journey. Go to careers.stryker.com and see the great options available for you. Kettering University is the leading university of choice for many first students. Kettering offers strong support for first alumni, including an alumni program and scholarships for first students up to $25,000. Schedule a virtual chat to get started at
Thanks for watching. If you
kettering.edu.
want more fun content, be sure to subscribe and ring the bell to be notified about our latest videos.
Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.